Okay, my recording stopped, so we're recording again. The last, we got the perimeter was 16 inches for that triangle, okay? Moving on. They will give some like this to you, and they will say, here is your shape. I want to know the probability of me throwing a dart and it landing inside of the circle in comparison to inside of the square, okay? So when we want a probability, we want the overall versus what we want. We want what we want on the top versus the overall. So what shape is the overall shape? Square. So it's basically like saying the area of the square is on the bottom and the area of the circle is what we want on the top. Okay? So the radius of that circle is 6. So area of a circle is going to be pi times the radius squared. So pi times 6 squared. But then we want the area of the circle, or the area of the square to be on the bottom. What is each side of the square going to be?
On the bottom, 12.
12, right? Okay, so it is a 12 by 12, right?
Yeah.
Okay, so what's the area of that square going to be? 12 times 12, which is 144. Okay, so on the top, I have 36 pi over 144. I can reduce both of those by... Take 144 divided by 36. See if it 36 goes into 144. 4 times. So this would be 1 and this would be 4. So it would just be pi over 4. You could figure that out as a decimal if you wanted to. But pi over 4 is the probability of it landing inside of the circle versus inside of the square. Okay, so they might do that to you. But think what you want to happen, which is the circle, over the total area, which is the square. Make sense? Okay. All right, last couple more. A new train comes every 15 minutes. What is the probability of a person waiting longer than 10 minutes? How do you do that? A new train comes every 15 minutes. What's the probability that somebody's going to wait longer than 10 minutes? Make a number line. Here's how long I'm going to wait. If I am real lucky, I will have to wait 0 minutes. If I'm unlucky, how much do I have to wait? 15 minutes, right? 0 to 15. Here is 5, here is 10, right? I could wait 5 minutes, I could wait 10 minutes. What's the chances of me having to wait longer than 10 minutes? A third, right? This would be 5 minutes out of a total of 15, or 1/3. Just make it into a number line, right? Make sense? Questions about that? Just make it into a number line. Just think about where it is on the relationship of time. All right, now this is a contingency table, and this is kind of probability. So I put these on here. This is my two-way frequency table, which has cancer, no cancer, positive versus negative. So people who tested positive for cancer that actually had cancer is 14. These people are doing what they're supposed to. This is really sad, but that's the result that we should get, right? If they have cancer, they should test positive for cancer. What else should happen? No cancer should be negative. This is another thing that should happen, okay? These people, these 4, are testing positive for cancer when they actually don't have cancer. That's like the J.C. Himmelbergs, right? He tested positive, so he had some sort of, cancer thing in his blood, and then turns out he didn't actually have it, okay? These 2 are doing also what they're not supposed to. They have cancer, but they're going through and saying, you're fine, you're fine, you're fine, you're fine, you're fine, right? And we've talked about which one would you rather be?
No cancer.
You would rather be no cancer negative, right? But of the 2 and the 4, I would rather be no cancer positive, right? I would rather be scared to death and actually not have cancer than go along, say you're fine, you're fine, you're fine, you're fine, you're fine, and then you die, basically. Right? Well, but if you're not treating it, it's going to eventually kill you. And you're not going to treat it if you say negative, negative, negative the whole way through, right? So, all right, here is different ways of writing this word. The word given can be written like this as a bar, or it can be written as the word if. Okay, all of those mean the same thing, and you always start with the given. Start with given. Okay, so in here we are given that the person is positive for cancer. So how many people are positive for cancer?
14.
18 total. So we got to do our total rows, okay? This would be 374. Total no cancer would be 376. And total cancer would be 16. So maybe do your total rows first. So how many people total are positive for cancer? What did we say? 18? Total positive for cancer. That goes here on the bottom. Now, how many of those people actually have cancer? 14. So 14 out of 18 or 7 over 9 are the cancer given that they're positive. Does that make sense?
Yeah.
Okay. Now this one. How many people have cancer? That's my new bottom number. Given that they have cancer. You start with the back and work to the front. Given that they have cancer. 16. How many people are negative given that they have cancer? 2 out of 16. So 1/8 of the people are negative that have cancer. That's bad. I made these numbers up, so these numbers are not true to what it would actually be. Okay. All right. What do we start with here? Last one.
No cancer. 376.
We start with the bottom number is the positives. How many people are positives?
16.
Nope.
I am
18. Total positives. This is the total positives. So 18. How many of those people don't have cancer? 4. So 4 out of 18, which is 2 ninths. 2 ninths. Right? Does this make sense?
Yes.
Start with the given, and they will write the given 3 different ways. They'll say given, they'll use this little bar here, or they'll use the word if. All of those mean the same thing, and you start with the given. That's your new bottom number. Okay? Was this kind of helpful?
Yes.
You're like, we could have not done this today and been okay?
Yep.
All right. Okay. Here you go. That's it.
No, that helped.